we're going to do division again, and this worksheet is kind of just an excuse to do division. It's called the remainder theorem. Nobody really uses the remainder theorem because there are just better ways to do it, but we get to use more division. So if I had x to the third minus 6x squared plus 4x minus 3, and I wanted to divide that by x minus 2, then I put x minus 2 on the left. I don't know how many columns there are going to be, but I bring down the first term and put it there. And then x times what is x to the third? That would be x squared. And then x squared times negative 2 is negative 2x squared. And now this block and this block need to add up to be negative 6x squared. So what do I put in that empty space? Negative 4x squared. Then I pull out an x, minus 4x, and that gives me 8x. Add a column. 8x and the empty block need to add up to be 4x. So I'm going to pull out, or I need a negative 4x, which gives me negative 4. Negative 4 times negative 2 is 8. Am I done? No, because this 8 needs to match negative 3, and it doesn't. Let me move all this stuff down. So I add another column, and 8 plus this number need to be negative 3, so this would be minus 11. And when I tried to take an x out of a negative 11, I can't, which means that's my remainder. And in elementary school, we used to write remainder negative 11. But that doesn't really help us at all. So instead, we do this. Plus, and then the remainder is negative 11 divided by the original denominator, x minus 2. Okay. Is x minus 2 a factor of that cubic equation? No. How do you know? It had a remainder. It didn't go in evenly. Okay. Now, this is kind of like box division. The way I learned it, it was called long division, and it looked differently. But this method always works. Anytime you want to divide two polynomials, this method will always work. But sometimes there's a method that is way faster that will give you the same answer. Okay? But it only works when the root of the denominator is an integer. Okay? If you set the bottom equal to 0 and you solve x equals 2, whenever this number is an integer, no decimals, no fractions, no square roots, then you can do something called synthetic division. Okay? And sometimes the denominator will have 2 roots, and synthetic division won't work. Well, it kind of does, but not really. So whenever the denominator has a single factor, and that factor has a single root that is an integer, you can do something called synthetic division. And it is so much faster than using the box. So here's how synthetic division works. You set the bottom equal to 0, and you get this number. Okay? And I'm going to put that number in the corner of my problem, and then I'm going to write down all of the coefficients of my equation. So 1, negative 6, 4, and negative 3. And I leave a little bit of a space, and I draw a line. And then at the end, I have another box, and that box is going to be my remainder. Okay? Now, you just follow a pattern. Multiply, add, multiply, add, multiply, add until you get to the end. The first step is you drop the first term. Okay? And then you take 2 times 1, which is 2, and you write it underneath the next term. And then you add. Negative 6 plus 2 is negative 4. And then you multiply. 2 times negative 4 is negative 8. Then you add. 4 minus 8 is negative 4. Then you multiply. 2 times negative 4 is 8. And that should be a... Did I mess up my original equation? Oh, no? No, I did that right. Okay, guys, where did I mess up? Ah, this is a negative 8, which means we need a plus 5. You guys didn't even stop me. Plus 5. And over here, I get 5. Okay? Now, the cool thing about this is, not only does it tell us the remainder 5, it also gives us the equation. So my original division was an x to the third divided by an x. What happens when you take x to the third and you divide it by x? You get x squared. So this was an x to the third and an x squared and an x and a constant. And after I do the division, this one becomes an x squared, and this one is an x, and that's a constant, and here's my remainder. You see that? This answer right here is identical to this answer right here. Okay? So if I had x to the fourth minus 2x to the third plus 6x squared minus 4x plus 8. And I wanted to divide that by x plus 2. Can I use synthetic division in this case? Yes. Why? I need to do that. Well, if you set the bottom equal to 0, and you end up with x equals negative 2, is this an integer? Yes. You guys know what integers are, right? Positive and negative whole numbers. So I put that number in the box, and then I write down all the coefficients. 1, negative 2, 6, negative 4, and 8. Then I drop the first term, and then multiply, add, multiply, add, multiply, add until you get all the way to the end. So negative 2 times 1 is negative 2, which gives me negative 4. Oh, this might be ugly. Negative 2 times negative 4 is 8, which is 14. And then negative 2 times 14 is negative 28, which gives me negative 32. And that's 64, which is 72. Okay, so what's the answer? Well, the answer is the original equation was an x to the fourth, so the new equation, the answer equation, is an x to the third. So 1x to the third minus 4x squared plus 14x minus 32 plus the remainder, 72 divided by x plus 2. Does that make sense? Okay. Now, that is how you do division, synthetic division. But sometimes your equation is going to be missing something. So let's look at number 13. 13 says x to the fifth plus 6x to the fourth minus 3x squared minus 22x minus 29, and I'm dividing by x plus 6. Can I use synthetic division in this case? Yes. What do I put in the box? Negative 6. So negative 6, and now you have to be careful when you write your coefficients. What are they? 1, 6. Does anybody see a problem? There's no x to the third. If I forget about x to the third, is that going to mess up my answer? Yes, because when I get to the bottom is supposed to have one fewer term than the top. But the numbers, the degrees need to match up. So anytime you skip an x to the third or an x squared, you have to put a placeholder to represent where it's not. And then -3, -22, and -29. Okay, so drop the first one, -6, or sorry, oops, that was brilliant. So 1, -6 times 1 is -6, which is a 0. 6 times 0 is 0, which is a 0. And 0, -3, and 18, which gives me -4, and 24, which gives me a -5. Now, this set of instructions says, state if the given binomial is a factor of the given polynomial. Is x plus 6 a factor of that polynomial? No, why not? The remainder was not. How do we know if it is a factor? The remainder would be 0. Okay? So, what does this -5 actually tell me? Well, the cool thing about division is the remainder tells you what the y value is of the graph when x equals -6. Okay, now, you might not have understood what that meant, but this equation right here, x to the 5th, looks something like this. Okay? If I plug in x equals -6, so I go over to 1, 2, 3, 4, 5, 6, the graph is down here at -5. So the remainder tells us where the graph is at that particular x value. So -6, -5 is a point on the graph. Well, what if this is a 0? What does that mean? It means the answer is on the x-axis, which means that -6 is a root. Okay, so look at number 1. It says evaluate each function at the given value. We want to know where is the y value when x equals 2? Well, all we have to do, we could just plug it in, right? So plug in 2. 2 to the third is 8. -8 plus 12 is 4. Minus 7 is -11. Okay, but we're going to do the same thing using division. So on number 1, put 2 in the box. And then what are my coefficients? -1, be careful, 0, and 6 and -7. Drop the -1. 2 times -1 is -2. 0 times -2 is -2. 2 times -2 is -4, which gives me a 2. And 2 times 2 is, wait, did I mess up? -2, -2, -4, 2. Oh, I added it up wrong in my head. So 2 times 2 is 4, and I get -3. So what's the answer? What do we get when we plug 2 into the equation? The answer is -3. So when x equals 2, y equals -3. Okay, so on the first 6, that's all you do. On the next 8, what are you looking for to find if it is a factor? How do you tell? If there's a remainder, the answer is no. If there's no remainder, the answer is yes. And then on the back side, you're just going to divide. But remember, synthetic division only works if the number in the box is an integer. If it's a fraction or a decimal or a square root or an irrational number, synthetic division does not work. Okay? Do you want to see how to divide again and how to write the answer? Want to see one more of those? Okay, um, let's do number 26. What number goes in the box for 26? -4. Am I missing any terms? Yes, I'm missing a 3 and a 2. So my coefficients are 8, 32, 0, 0, 5, and 20. So drop the first term. -4. Oh my goodness, I did it again. -4 times 8 is -32, which gives me a 0. -4 times 0 is 0. 0 plus 0 is 0. -4 times 0 is 0. 0 plus 0 is 0. 0, 5, and -20, which gives me a 0. Wow. So it's always, you need to always look. This is x to the 5th. This is x to the 4th. And then this is x, and this is a constant. So I'm missing the x to the 3rd and the x squared. So you have to make sure they're in order. And actually, if you scramble the order, this won't work. So they have to be in order. And anytime one of the terms is missing, you put a 0 in its place. Okay? So my old equation started with x to the 5th. So my new equation starts with x to the 4th. So it's 8x to the 4th, and technically plus 0x to the 3rd plus 0x squared. Okay, does that make sense? And then if there was a remainder, then we would do this. But there wasn't, so we don't need to worry about it. All right. Okay, get to work.